Hey everyone, today we're going to go over lesson 7-3, logarithms and logarithmic functions. As usual, pause the video as needed, and let's go ahead and get on. All right, so previously in chapter 6, which we actually haven't covered, we're going to go back to that. We're doing things a little out of order this year. We're doing chapter 7 first. We're going to find the inverse of function, and we will go over that in more detail later. But we're going to evaluate logarithmic expressions, graph them, as well see how they are related to exponentials. So logarithm and logarithmic functions, you probably haven't really heard of those before. You might have heard them in your science class, maybe not. It depends on which science you're in. But those are some of our new vocabulary that we will be using. We typically short logarithm to the word log, L-O-G, and I do know if you've used a scientific calculator, you probably have seen that button on there. So one of the key things we have for a logarithm with base b is that let b and x be positive numbers, b cannot be 1, and the logarithm of x with base b is denoted by log base b of x. That is how we say this part here, and is defined as the exponent y that makes the equation b to the y equals x true. So this relates to an inverse function in that it's kind of inverse is how you undo something, and when we look at functions itself, to find the inverse of a function, we switch x and y and solve for y. So pretty much we have a shortcut for logarithms to go ahead and do this in switching between logarithms and exponentials. So log base b of x equals y is if and only if b to the y equals x. So for example, log base 3 of 27 equals y. That would mean 3 to the y equals 27. They're the same thing. They are the inverse of each other, or we would have the inverse. So first thing we're going to do is go ahead and write log base 3 of 9 equals 2 in exponential form. When you have one completely with all the numbers in there, sometimes it's easier to go ahead and write it based on what you know versus maybe you're trying to follow a pattern, such as I need to use 3, 2, and 9. Something has to equal another. And sometimes it's easier just to know that 9 is equal to 3 squared. If you know that, it kind of helps you identify where things go on a problem where you might not know where things are or what they are. So 9 equals 3 squared. You could also write 3 squared equals 9. So here we have log base 10 of 1 over 100 equals negative 2. So this would be the same thing as saying 1 over 100 equals 10 to the negative 2. Go ahead, pause the video and give this one a try. All right, so looking at this, we should get 2 cubed equals 8, so my answer would be B. Here's your second U try. Go ahead and pause the video. Give it a shot. All right, so on this one, we should get 3 to the negative 2 equals 1/9. So our answer is C. Going on to example 2, what we have here is now we're going backwards or in the other direction. We have an exponential, now we want to go to log. So 5 cubed equals 125 would be the same thing as log base 5 of 125 equals 3. Next we have 27 to the 1/3 equals 3. That would be the same thing as log base 27 of 3 equals 1/3. Do pay attention to how you do say this, because the way you phrase it tells us how to write it, just as a heads up. All right, go ahead and try this problem. Pause to give yourself a time to try it. All right, so we should get log base 3 of 81 equals 4, which is A. Pause the video to try this problem. All right, we should get log of 81, or I'm sorry, log base 81 of 9 equals 1/2. Next, we're going to go ahead and evaluate. So this would be, they just give you this and they want to know what happens. This would also be useful when we're trying to plot points on a graph that you would need to do this. Um, so they have a couple thing ways we can do this one. They're going to change it to an exponential and then go ahead and solve for the exponent, which in this case would be 5. That is one way you can do it. Our other option, which we could do, especially base 10, if you do not see a number here, you're to assume the base is 10. We live in a base 10 system. That's how we count things. It's just how things are. So we live in base 10. So when you don't see it, base 10. That if you just see a log button on a calculator, it's going to be base 10. If you are using an Nspire or Desmos, specifically on the Desmos graphing calculator, you can actually determine your base and change it as you want. I will say sometimes it is a little picky on Desmos when you're typing it in. So I am going to go ahead and show you that momentarily to give you a chance to see it. And we are actually going to compare the two calculators so that you can see what I'm talking about, since most of you probably will be using Desmos to do your problem, your homework. So the first one is we're going to go to the graphing calculator. On the second one, we're going to go to a scientific calculator. Very important, very easy to get to. You're going to press function. Now, in the scientific calculator, it's not going to let you pick your base. It's going to use base 10. And I can tell that when you do base 10 of 10, you get 1. So you're not going to be able to pick the base that you want to use. I've played with it. If you know another way to do it, let me know. However, in the graphing calculator, you can go to functions, miscellaneous, and then you see this little log base A, and you can actually type in the number you want there. 243. So there is the example that we did do earlier. You can type it. You do need to be careful if you're trying to manipulate it, because if you hit delete one too many times, notice I can't get back to how it used to be. The base disappears. Now it's in base 10. So do be careful when you're using that and you're typing it up. But go ahead and try this problem. Pause the video to give yourself a chance of time to try it. And you should get 3. Moving on to the parent function of a logarithm. So we have log base b of x, where the domain is all positive real numbers, and the asymptote is at f of x, or the f of x axis, or the y-axis, is continuous and 1 to 1. The range is all real numbers, and our intercept is at 1, 0. And we have 2 different ones. It's kind of like we have a growth and a decay one, if you want to think of it that way. It's not really quite that, but when b is greater than 1, we have it going up and to the right. When b is between 0 and 1, it is going down and to the right, so it's decreasing in value. Typically, we tend to look, say, base 10 is usually the base we use, so we usually look at this problem here. But it's continuous and 1 to 1, which is very important to note. Give yourself a chance to pause the video to go ahead and copy this down. But we're going to head and move forward now. So graphing log base 3 of x. So this is where we're saying like determining points. We're actually just going to head and use Desmos, and you can pull your points from there. But you would plot your points. And what they're using here is actually the I'll let you disappear. 1 over, they're basically using the inverse of an exponential. So you would just plot your points and graph it. we're gonna just, for the most part, this doesn't really apply to us because we are just gonna go ahead and use the graphing calculator. We typically don't graph these by hand anymore. And if you graphed this one, you would get D. Sorry about me moving too fast. Go ahead and graph this one and using Desmos. By using Desmos, you should get A. We do have our transformations. A, H, and K are exactly the same. Horizontal translation, vertical translation, and then orientation and shape. Exactly the same as they've been all year long. We do have B that kind of just determines the shape of the graph that we don't talk about as much. But if you still have, for some reason, not copied down this information, you need to go ahead and copy it down now. The only thing I would add here is that H is also going to be your vertical asymptote. So we can take a look here and we can take a couple things that we should know about the graph itself. I know my A value is 1/3, so it is a vertical compression by 1/3, and that my K value is -1. For your H values, when you have an H value other than 0, you're going to see parentheses. If there's no parentheses, then that value, this number here, is going to be a K value. And as they show you here, that K is -1. This just tells us what's happened. And so you can kind of just guess the shape of it without graphing too much of it. So here we have A is 4, so it's a stretch, it's growing faster. And notice here we have parentheses. So this is how I know it's a horizontal shift of -2. So we're going to go to the left 2 units. And that does change this. And as you notice, since you cannot actually take a negative log of a negative number here, your H value determines your horizontal asymptote. And when you actually graph this, if you go past -2, if you go to -3, -2.5, it's going to say error or undefined. So using Desmos, go ahead and graph this problem. And you should get B. All right, using Desmos, go ahead and graph this problem. You can also use the fact that you know your vertical asymptote. All right, with that, you should get D. One of the hints we have here is that it is a -1, which means we move to the right one. So we're going to have it invisible. If I could, I would. It's not going to let me Control P. There we are. We're going to have, just going to draw a straight line. There's an invisible asymptote here at 1. So that was one of the things you could do. I'm not really great at drawing freehand using the keypad. So that is one of the things you could use when you're trying to graph these or trying to narrow down answer choices, since they give such clear numbers. So here's a real world example. At Earth's surface, the air pressure is defined as 1 atmosphere. Pressure decreases by 20% for each mile of altitude. Atmospheric pressure can be modeled by P equals 0.8 to the X, where X measures the altitude in miles. Find the atmospheric pressure in atmospheres at an altitude of 8 miles. So we have our original equation, and we're going to substitute 8 for X, and we get 0.168. So that is our answer. Part B of this is write an equation for the inverse of this function. So we were going to switch X and P, and then we're going to have to solve for that by rewriting it as a logarithm. So P equals log base 0.8 of X. All right, go ahead and try this problem. Pause the video to give yourself a chance or time to work on it. All right, you should get B. You're going to go ahead and just plug in 50 for X. Oh, I'm sorry, 350 for x. Find the air pressure in pounds per square inch after driving through 150 where x measures the. Actually, I lied. You're going to plug in 7 for x if you were lost, because you have 7 50-mile trips within 350. And then they want to go ahead and have you convert this to a logarithm of the inverse. So I'm going to have you pause the video, give yourself a chance to try it. All right, so you're going to switch p and x. So I'm going to head and write that. So we're going to get x equals 44.99 to the x. It doesn't really matter if I'm on the inside or the outside for the x right here, because it's only going to apply to that 99. So to solve, we're going to go ahead and change this to a logarithm. But before we do that, you need to go ahead and move the 44 over. So I would divide by 44 on both sides. And I'm sorry, I'm using the keypad on my computer instead of a mouse. So it is a little bit more time consuming. So that's going to go away. And so we would get log. So this will switch to over here, 0.99. Oh, it's down here. Of, and then this switches. I'm just going to put of x. I'm going to put x here. Fraction, and I'm just going to put 0.4 because I am having some issues here. And that would equal p, which is my exponent here. So my answer is D. That is the end of the lesson. Next time we will go over 7-4, and I will see you next time.